3/4 of all living organisms on Earth died out in the Cretaceous-Paleogene extinction. Almost all creatures heavier than 25 kilos ceased to be, including practically all non-avian dinosaurs. This tragic event heralded the end of the Mesozoic and the beginning of the Cenozoic, the geologic era that is still not over. It is divided into 3 periods of various duration, which are different both in terms of climate and diversity of the biosphere. The first and longest is known as the Paleogene. It began around 66 million years ago and continued for 43 million years. In the first 10 million years of the Paleogene, the Earth's biosphere was recovering from the hard blow dealt by the mass extinction. This geological epoch is referred to as the Paleocene. Since great numbers of dinosaurs and other species of the Cretaceous had perished, there were lots of vacant ecological niches for the taking. These were promptly filled by the new masters of our planet, mammals. The geography of the Earth of that period was drastically different from what we're used to seeing today. Looking at a map of that prehistoric Earth, we would already be able to make out the familiar continents, but they were positioned slightly differently. Thus, North and South Americas were separated by tropical seas, while the Indian subcontinent was just starting to make for the Asian shores. The prehistoric ocean, known as the Tethys, still lay between Africa and Eurasia, but was already largely giving way due to the movements of tectonic plates. The climate of the epoch was warmer and more stable than today's. Most of the planet was covered with dense and lush tropical forests. The overwhelming majority of the living creatures of the day were quite small. Thanks to the abundance of vegetable food, they quickly propagated and spread across more and more new areas. This is when the prehistoric ancestors of most of today's mammals thrived. For example, the warm forests of the Paleogene were inhabited by miacids, small and deft predators that looked like martens. It is believed that they were the progenitors of all today's rich diversity of mammal predators. At around the same time, there lived archaeocetes, the prehistoric ancestors of today's whales. At the time, however, they looked more like hippos. They hadn't gone to live in the sea yet, but had made their first steps in that direction. Their limbs, respiratory organs and the inner ear had already started to adapt to prolonged stays underwater. The next epoch our planet went through was the Eocene. It began approximately 56 million years ago and continued for slightly over 22 million years. The contours of the continents had already grown to be quite recognizable. India had finally made it to the southern shores of Asia, and as a result of the collision of tectonic plates, giant rock folds formed. That is how the Himalayas rose, the largest mountain range on our planet today. Even though some species of that time already looked like some we might come across today, others were completely different. An example of one of these is Andrewsarchus, one of the largest mammal predators that has ever lived on the Earth. Its skull measured up to 84 centimeters, which is roughly 1.5 times more than that of the brown bear, and its bite is estimated to have been harder than that of any of today's land predators. It has been inferred from the deep tooth sockets in Andrewsarchus's skull, where mandible muscles were attached to, which leaves no doubts as to the bite's crushing force. Reconstruction of its skeleton shows that the animal could measure over 4 meters in length and weigh as much as a ton. Still, interestingly, it looks like this giant carnivore fell into the class of primitive ungulates. Research showed that Andrewsarchus's closest relatives were the prehistoric suiforms, hippopotamids and cetaceans. Studies of a few unearthed fossils of its skull and teeth show that the animal must have been omnivorous and even didn't mind eating carrion. Unfortunately, not many bones and fossils of this fascinating creature have been found, and scientists are still at odds as to the structure of its organism, habits and relation to other mammal families. The Oligocene was the last epoch of the Paleogene. It is posited that it began around 33.9 million years ago and was over about 23 million years ago, which makes it roughly 11 million years long. This was a time of global cooling. The warm tropical forests were gradually superseded by endless prairies covered with grasslands. This is when the Antarctic glaciation began, and an icy shield transformed the green continent of the pole into a lifeless, cold desert. Australia continued to drift away from the other continents, while Africa, on the contrary, was making for the north to meet Europe. After a collision of tectonic plates, mountain ranges formed, and that is how the Alps made their appearance on the map of the world. Around 26-28 million years ago, the supervolcano La Garita furiously erupted on the territory of today's Colorado. In fact, it was one of the major volcanic emissions of the entire Phanerozoic eon. An area of over 30,000 square meters was buried under a layer of hot ash as much as 100 meters thick. All life within a huge radius around the volcano was destroyed completely. Amazingly, life is able to come to terms with any disasters. The Earth of the time was inhabited by fascinating creatures, some of which were not smaller than dinosaurs in size. For example, Indricotherium, a prehistoric herbivore related to rhinos. Paraceratherium, the largest of these, reached 4.8 meters in shoulder length, which is higher than a large African elephant. Thanks to their remarkably long neck, these giants were able to raise their head up to 7 meters above the ground. Today's rhino would be able to pass under its enormous progenitor's belly, while a human would hardly reach up to touch its knee. With their mass reaching 20 tons, these giants were the largest land mammals of all times. Even Brontosaurus, the most massive of land dinosaurs, weighed just around 15 tons. It still hasn't been established for certain what Indricotherium looked like. Unfortunately, not one entire skeleton of these amazing animals has been excavated so far, only separate fragments from different animals of the species. Most scientists agree that in spite of their relation to rhinos, Indricotherium didn't have a massive horn, although it may well have had a small nose trunk, like today's tapirs. The trunk would have allowed it to pick juicy leaves off treetops. These giant herbivores must have lived in small herds and were constantly on the move around vast stretches of land, roaming across their dominions in search of food. Unfortunately, by the end of the Oligocene, Indricotherium had died out completely. At around the same time, the areas they used to inhabit were explored by prehistoric elephants alongside large predators, hyenodons and amphicyonids. The latter are also known as bear dogs. It is thought that the emergence of new large herbivores would have greatly upset nature's balance, and Indricotherium would have been forced to fiercely compete for its food. Famine and the threat from the new dwellers of the Asian prairie gradually led to the herbivore's giants' total extinction. Apart from those mentioned, there were some other large predators who were quite common on the Earth in the period from 37.2 to 28.4 million years ago. Entelodons. Fossilized remains of these creatures have been found all over Eurasia. Being even-toed ungulates, entelodons resembled wild boars, although in terms of evolution, these creatures are closer to hippos or even cetaceans. Measuring up to 2 meters in length, they weighed over a ton. A meter-long head had huge jaws complete with all sorts of teeth, sharp incisors, long fangs and wide flat molars. It is likely that entelodons were omnivores with a preference for predation. Not hampered by their impressive size and bulk, they were able to develop remarkably high speeds, so chances of outrunning such a monster were quite thin. A wild boar the size of a large bull that prefers meat posed a serious threat to any inhabitant of the Earth of that time. That is why it is hardly surprising that entelodons successfully struggled for their survival for such a considerable time. The period in the history of our Earth that came next was the Neogene. It began approximately 23 million years ago and ended just 2,580,000 years ago. This is when our planet started to look almost, but not quite, what it looks like today. The continents shifted to their today's positions on the planet's surface, and the looks of the most of the plants and animals of the day grew to be familiar to our eye. With the Earth's climate gradually becoming colder and with droughts occurring more often, polar caps were gradually growing, which culminated in a global glaciation at the end of the Neogene. The planet, meanwhile, was crawling with all sorts of fascinating creatures. The deep-sea dwellers were terrorized by Megalodon, a giant shark measuring 15 meters in length and weighing up to 35 tons. On land, various gomphotheriums could be seen, creatures related to today's elephants. Many of them were the proud owners of 4 solid tusks. As for the animal's size, some were larger than today's African elephant, whereas others were quite modest in comparison. Around 2.5 million years ago, there started the Quaternary, which is currently the last geologic period in the history of the Earth. It is remarkable for the emergence and evolution of Homo sapiens, as well as its prehistoric ancestors. For example, in the period from 1 million years ago to 100,000 years ago, there lived Gigantopithecus, one of the species of great human-like apes known to science. They measured 3 to 4 meters in height and weighed over 500 kilograms. These creatures lived on the territory of Asia and were related to today's orangutans. It appears that Gigantopithecus would not be able to climb trees like other human-like apes on account of its mass. However, some of them are known to have dwelt in mountainous areas and made homes in natural grottos, caves and ravines. Even though their diet is believed to have consisted of mainly bamboo, bones of herbivorous animals with tooth marks were unearthed in their shelters. Judging by these finds, it is safe to assume that these creatures didn't mind meat and were omnivorous at the very least. The Gigantopithecus' skeleton is similar to that of a gorilla, so they were likely to use all 4 limbs to move around. Besides, these human-like apes had a comparatively large brain, which means that they could be relatively intelligent and were probably able to even make primitive working tools. Unfortunately, the population of these amazing giants sharply dropped when the prehistoric ancestors of today's human emerged and spread across the planet. By around 1 to 300,000 years ago, they had died out completely. Sadly, not many remains of Gigantopithecus have been found, which greatly impedes studying them. As they were spreading across the Earth, primitive human tribes eliminated many other creatures. One of their victims was Megatherium, a giant grounds-human tribes came to South America. The powerful but sluggish giant was helpless under a barrage of sharp spears and arrows, and very soon its population dropped to 0. Other giants who supposedly became extinct because of humans were diprotodons, which inhabited Australia in the period from 1.6 million years ago to around 40,000 years ago. These creatures were the largest known marsupials, and they were related to wombats and koalas. Some of these amazing animals reached as much as 3 meters in length and 2 meters in shoulder height. As for their mass, they weighed approximately 3 tons. This makes diprotodons quite as big as some hippos. Massive and herbivorous, they dwelt on massive woodland and coastal grass-covered plains that abounded in Australia before humans had made their appearance there. Chronologically, the extinction of the marsupial giants coincides with first human tribes arriving to this continent. Still, some scientists maintain that the extinction was caused not by hunting, but an anomaly of the Earth's magnetic field together with a local temperature decrease. The heightened radiation background, coupled with cooling, slowed down plant growth, which led to famine among the herbivores. Thus it appears that by and large the tragedy was inevitable, and the humans simply brought it to a close faster. The last epoch of the Quaternary, the Holocene, heralded a robust development of the human civilization, when Homo sapiens spread across the entire planet and dominated all the other inhabitants of our Earth. The downside of this evolution is manifested in a number of industrial disasters and irreversible changes in nature's balance. For example, it is due to human activity that the greenhouse gases concentration in the Earth's atmosphere is getting worse every year. This may globally negatively affect all living things on our Earth, from simplest bacteria to elaborate multicellular organisms. Unfortunately, the number of fascinating creatures living on our Earth is going down every year. It is particularly poignant to realize that they perish because of human stupidity or avarice. Uncontrolled hunting, irresponsible land development and indifference to the environment have already made scientists speak of a new, 6th Great Extinction event, whose consequences are potentially just as grave as those of the previous 5. Will mankind stop before it eliminates itself? How long should it take our planet to recover from the consequences of the technological progress? And will nature produce radically new life forms that would weather this crisis? just like it happened before? We can hardly realistically answer these questions. Have a chat with your friends about this if you feel strongly about the issues raised here, and give us a thumbs up if you enjoyed the video. As you know, it takes us a lot of time and effort to make every video interesting and informative, and your support means the world to us. Let's keep in touch.